It's really easy to get yourself in a muddle when we're trying to explain the redox behaviour of the group 7 elements. Their strength as oxidising agents increases as we go up the group. So fluorine is a very strong oxidising agent, iodine is not. Standard electrode potentials give us a feeling for how much an element wants electrons. The more positive the value, the more the element would like to gain some electrons. So fluorine, very keen on gaining electrons. Iodine, not so much. In order for fluorine to find some electrons and get itself reduced, because reduction is the gain of electrons, it must oxidize somebody else. So that somebody else has got to give up its electrons so that fluorine can gain them. And that is why fluorine is such a strong oxidizing agent. A classic example of this is the displacement reaction. During this reaction, chloride ions become chlorine. So the half equation, 2Cl- going to form Cl2 plus 2 electrons. These chloride ions have been oxidized. Their oxidation state moves from -1 to 0, and they give up electrons. These are the electrons that are going to reduce the fluorine to fluoride ions. So F2 is going to take the 2 electrons, these 2 electrons that the chlorine gave up, and it is going to be reduced to form fluoride ions. Oxidation state moves from 0 in the element to -1 in the fluoride ion. So although the fluorine itself has been reduced, it is behaving as a very strong oxidizing agent because it is causing the chloride ions to be oxidized to chlorine. Now, if fluorine is a strong oxidizing agent, then that tells me that the fluoride ions are very poor reducing agents. In order for the fluoride ion to be a reducing agent, we need the back reaction to happen. We need the fluoride ions to give up their electrons and be oxidized back to fluorine, and that's just not going to happen. In contrast, if we know that iodine is not a strong oxidizing agent, then that would imply that iodide ions are a strong reducing agent. When iodide ions are acting as a reducing agent, we've got this back reaction going on, which produces electrons, and these are the electrons that are used to reduce somebody else. The trend that we're now looking at is as we go down the group, the halide ions become stronger reducing agents. Iodide ions, strong reducing agent, fluoride ions, definitely not. We can see this behaviour really clearly when we look at the reactions between halide ions and sulfuric acid. Let's start with iodide ions. So iodide ions in the form of sodium iodide react with sulfuric acid, concentrated sulfuric acid, to form sodium hydrogen sulfate and hydrogen iodide. However, because these iodide ions are really strong reducing agents, this is not the only reaction that happens. These iodide ions are strong enough reducing agents to reduce the sulfur in sulfuric acid from an oxidation state of +6 to an oxidation state of -2 when the sulfur is in hydrogen sulfide. And the iodide ions themselves are oxidized. Bromide ions also behave as reducing agents, but they're not as strong a reducing agent as iodide ions. If we drop concentrated sulfuric acid onto sodium bromide, then we make sodium hydrogen sulfate and HBr, just the same as before. And the bromide ions go on to reduce the sulfur in the sulfuric acid from an oxidation state of +6, as before, to an oxidation state of +4 in sulfur dioxide. So bromide ions are not as strong reducing agents as iodide ions. The sulfur is reduced, but this time from +6 to +4, not +6 to -2, as is the case with iodide ions, and the products of the reaction are different. So what about chloride ions? Well, chlorine is a relatively strong oxidizing agent, so chloride ions are relatively poor reducing agents. In fact, if we drop concentrated sulfuric acid onto sodium chloride, we make sodium hydrogen sulfate and HCl. But the chloride ions are not strong enough reducing agents to reduce the sulfur. So there's just one reaction going on here. So the redox behaviour of the halogens of group 7 can be summarised as so. As we move up the group, the elements become stronger and stronger oxidizing agents. As we move down the group, the halide ions become stronger and stronger reducing agents. You can find out more about group 7 chemistry at crunchchemistry.co.uk.